Hi, ladies and gentlemen. Notes 5.6 are on factoring trinomials. This is part 2. So before we do anything, I just want to quickly review what we need to do for question number 1 and question number 2. This is going to help us out with our factoring piece. So we'll use the box for the first one, and then we'll use FOIL for the second one. You can do either one, whichever method you like better. It's totally up to you. So I'm going to put x minus 2 here and x plus 2 here. And x to the power of 1 times x to the power of 1 is x to the power of 2. X times negative 2 is negative 2x. 2 times x is 2x, and 2 times negative 2 is negative 4. So when I put these two together, what ends up happening is this 2x and this negative 2x completely cancel each other out. So I end up getting x squared minus 4. Okay? And then for this next one right here, we've got x minus 9 times x plus 9. Sorry, I said we would do FOIL for this one. So I'm going to multiply x times x. If you want to use the box, use the box. That's totally fine. So right here, x times x is x squared. And then when I do x times 9, I get 9x. When I do negative 9 times x, I get negative 9x. And then when I do negative 9 times 9, I get negative 81. Well, these cancel each other out again, so we get x squared minus 81. So if you notice, what will end up happening is that if we have x plus some number and then x minus some number, and it doesn't matter whether it's plus first or minus second, but they have to be opposites of each other, the middle terms will always cancel out. And this is called a difference of perfect squares. And before we explain why it's called a difference of perfect squares, what will end up happening is this will turn into x squared, because x times x is x squared. When I do the outer and the inner, those cancel each other out, so I just have minus a squared right here. And it's called a difference of perfect squares because there is subtraction. And they're perfect squares because the numbers can be square rooted. Okay, so let's go ahead and look at how to factor questions 3 and 4. So in question 3, this is a difference of perfect squares because this is a perfect square, this is a perfect square, and there's subtraction. So if I were to factor this right here, what would end up happening is I know that this times this gives me x squared, so x times x is going to give me x squared, and I know this times this will give me negative 64, and they have to be the exact same number. So I'm going to take the square root of 64, and when I square root 64, I see that it's 8, and the reason why it's 8 is because 8 times 8 is 64. So here this is an 8, this is an 8, one has to be plus, and one has to be minus. Okay, let's talk, and this is my answer. Let's talk about how this works in the box. So in my box right here, I will end up getting inside of here, I know this is x squared right here. I know that this is negative 64, and I know that there's no x's here, so they have to cancel out. So the only way that this is going to work is if I put an x here and an x here. And if I put the same number here as I do here, but one of them has to be positive and the other one has to be negative for these to cancel out. And that's how we get x plus 8 times x minus 8. Okay? All right, let's try the next one, please. So if we take a look at this next one right here, this times this has to give me x squared. So x times x will give me x squared. And then this times this has to give me 25. So it has to be 5 times 5. Okay, and then one of them has to be plus and one of them has to be minus. So this is my answer here. Let's verify with our box to make sure that this is correct. So right here, this needs to be x squared Right here, this needs to be negative 25, so I'll put x and x, and then 5 and 5 have to go here to get these to cancel out, but one of them has to be negative in order for this to work for me, okay? Okay, so now we've learned about 3 different types of factoring problems, and what we need to do now is be able to identify which type of factoring problem is which, okay? So if it's a factor by GCF problem, then we will know it's factored by GCF by the fact that there are common factors with every term. So you're going to always ask yourself, is it a GCF question? If it's not, then we're going to try to look at a difference of perfect squares. So in order for it to be a difference of perfect squares, remember it's a squared minus b squared. So there are 3 conditions that have to happen. Okay? The first condition is that it has to have subtraction. If there's no subtraction, then it doesn't work. The second condition is there have to be 2 terms, okay? And then the third condition is that it has to have perfect squares, so numbers that can be square rooted. So we'll say you can square root. Okay? And then if it's an unfoil question, then we know it's unfoiled by either trying the box and it works, or guess and check works. Okay? So let's take a look at question number 5. It says, identify the following examples. Is it a factor by GCF, an unfoil, or difference of perfect squares problem? So we're going to go through each one of these to see what type of a problem it is. So the first one is factor by GCF. So I'm going to look at A, and I'm going to see, is there anything in common with 3 and 9, and with x squared and x? And there is something in common. So because there's something in common, there has to be a GCF is 3x, so this happens to be a GCF problem. Okay, so now let's look at B. Question B, let's go through our list. So factor by GCF, there are common factors with every term. So I've got x squared, negative 5x, and negative 6. And I want you guys to write down not 1, because there's always going to be a 1 in common, okay? So right here, x squared and negative 5x have an x in common, but there's no x in common with the 6 here. So for this right here, there's no x in common. And 1, 5, and 6 have nothing in common either. So for GCF, it does not work because there's nothing in common. Okay, now let's take a look at the next one, which is a difference of perfect squares. So for difference of perfect squares, it has to have subtraction, which it does, but it has to be 2 terms. And this right here is 1, 2, 3 terms, so it's not a difference of perfect squares, okay? And this one right here for unfoil, it says we either try the box and it works or guess and check works, and it does work because if you take a look right here, we need to have x squared here. We need to have negative 6 here. We need to have negative 5x here. So if I put an x here and an x here, and if I put a 6 here and a 1 here, this gives me 6x, this gives me 1x, and I can get negative 5x if the 6 is negative. So it's an unfoil question. Okay? All right, so now let's look at question C right here. So I'm going to list all 3 types of problems out over here, and we're going to cross off the ones that don't work. So, sorry, right here, difference of perfect squares or unfoil right here. So when I take a look at this right here, I've got 3x squared y minus 9xy squared. So when I look at this, the first one is GCF, and there has to be common factors with all the terms. So right here I've got 3x squared y. Here I've got 9xy squared. So they have a 3 in common, they have an x in common, and they have a y in common, so it has to be a GCF problem. But let's see why it's not an unfoil problem. By the way, for unfoil, we need to add one more piece of information that's really important. There has to be 3 terms for an unfoil problem. Okay, so let's look and see, is this a difference of perfect squares? Well, there is subtraction, but 3 is not square rootable, and y is not square rootable. So it's not a difference of perfect squares, okay? And in order for it to be unfoil, it has to have 3 terms, and it doesn't. So this is also a GCF problem, okay? All right, our last one right here, let's make our list. So GCF, difference of perfect squares, or unfoil. So looking at this right here, GCF, there has to be something in common with both of these. There isn't, so it's not a GCF question. For a difference of perfect squares, there has to be subtraction, which works. It has to have 2 terms, which we do have. We have 2 terms, and I can square root x squared, and 9, the square root of x squared is x, and the square root of 9 is 3, so it has to be a difference of perfect squares. Okay, and then lastly, is it an unfoil question? There has to be 3 terms. There's only 2 terms here, so it's not an unfoil question, so it has to be a difference of perfect squares. Okay, all right, awesome. So let's go ahead and try some questions here now. All right, so let's try some of these examples here. So we have 3 options. It could either be GCF, it could be a difference of perfect squares, or it could be an unfoil question. And you're going to have to flip back and forth between this page and the previous page in order for you to be 100% sure that you are okay with this stuff. Okay, so right here, the first one that we have is x squared minus 49. So if you notice right here, x squared minus 49 has nothing in common, so it's not a GCF question. So we can cross off that it's not a GCF question, okay? Next one is difference of perfect squares. So remember, for difference of perfect squares, it has to be subtraction. It has to have 2 terms, and it has to have perfect squares. In order for these 3 things, in order for us to have a difference of perfect squares, these 3 things have to work out for us. So if you notice right here, we do have subtraction, we do have 2 terms. The square root of x squared is x, and the square root of 49 is 7. So this does work. So it's a difference of perfect squares question. So we're going to say it's x plus 7 times x minus 7. And that's my answer for this question right here. Okay. All right, so now let's take a look at our next one that we have here. So for our next one, it says x squared minus 1, right? X squared and negative 1 don't have anything in common, so it's not a GCF question. For difference of perfect squares, it has to have subtraction. It does. It has to have 2 terms. It does. And I can square root x squared and get 1, and I can square root 1 and get 1. So it is a difference of perfect squares. And let's write out here that this one is also a difference of perfect squares, so we know that this is the right type of problem. So here, this is a difference of perfect squares. So here, what we're going to do is we're going to say it's going to be x plus 1 right here, and x minus 1. And if we were to multiply this out, we would get x squared minus 1. Okay, so taking a look at number 3, let's go through our list of things again. Okay, so 4x squared and negative 9 have nothing in common, so it's not a GCF question. If it's a difference of perfect squares, it has to have subtraction. It does. It has to have two terms. It does. And these are perfect squares because the square root of 4x squared is 2x and the square root of 9 is 3. So this is another difference of perfect squares. Okay, so we're going to say that our answer is going to be 2x plus 3 times 2x minus 3. And if you notice, if I were to actually do the box for this right here, in order for this to work out for me, I would need 4x squared here, I would need negative 9 here, and then these two should cancel out. So if I put 2x and 2x here, that gives me 4x squared. If I put 3 here and 3 here, that gives me 9. I need one of them to be negative, so this will be negative 6x because negative 3 times 2x is negative 6x, and 2x times 3 is 6x. So these 6x's cancel each other out, and that's the answer right here. Okay? All right, so let's take a look at number 4. Number 4 says 2x squared minus 8x. So if I take a look at what we have here, if it's a GCF, there's something in common with both terms. Well, there's an x in common with both terms, and there's a 2x, or there's a 2 in common. So this is a GCF question, and the GCF is 2x. So I'm going to factor out a 2x, and when I divide 2x squared by 2x, 2 divided by 2 is 1. X squared divided by x to the power of 1 is x to the power of 1. Okay, and then here I'm going to copy down this minus sign. 8 divided by 2 is 4. X to the power of 1 divided by x to the power of 1 cancels, so this is my answer right here, and I'm done with that question. Okay, all right, 2 more to go. The next one right here is x squared minus 16. So I'm going to look through and see, is there anything in common with x squared and 16? And there isn't, so it's not a GCF question. Okay, then I'm going to look and see, is there subtraction? Yes. Is it 2 terms? Yes. Can I square root both of these terms? Absolutely. The square root of x squared is x. The square root of 16 is 4. So this ends up being x plus 4 times x minus 4. And this is a difference of perfect squares problem. So we'll write down here that this is a difference of perfect squares question. Okay, all right, our last one that we have here, so this is our final answer. Our last one that we have here, let's go through our list right here so we can see it's x squared, we can see that it's x squared plus 4x plus 3, okay? So I'm going to go down my list. Is there the GCF? Is there anything in common with all 3 of these terms? There isn't, so there's no GCF. Is it a difference of perfect squares? So there has to be subtraction. There isn't. It has to be 2 terms. There aren't. There are 3 terms, and I can't square root 3. Okay, so this is not a difference of perfect squares. So now, can I unfoil it? If I can unfoil it, there needs to be 3 terms. So since there are 3 terms, I'm going to try to unfoil it. Okay, so let's go ahead and do this in our box right here. So we know right here that the x squared has to go here. We know that the 3 has to go here, and we know that this box and this box together give us this 4x right here. Okay, so in order for this to work for us, I need an x to the power of 1 here and an x to the power of 1 here. Okay, and in order for this to work for us, we need to find numbers that multiply together to give us 3. And that's nice because it's just 1 times 3. So I'll try a 1 here and I'll try a 3 here. So 1 times x is 1x right here. 3 times x is 3x right here. And 3x plus 1x does give me the 4x that I want right here. So that works out for me. So and in order for it to work out for me, these both have to be positive. So first of all, we're going to write down that this is definitely an unfoil question, and if you look right here, this is x plus 1, and if you look right here, this is x plus 3, and that's our final answer. And that's how you do this lesson. All right, let me know if you have any questions. Good luck with the problem set. Make sure you get the practice so you can make sure that you really have mastered this material. All right, have a great day.